All right, so let's talk a little bit more in depth, guys, about these two types of artificial transmutation. So again, change in the nucleus is caused by bombardment. So you're bombarding, you're slamming different particles into the nucleus of an atom. You need to make sure that it's a high energy particle that you're using as well. All right, such as a neutron or an alpha particle. So this is actually what's happening in France and Switzerland at CERN, all right, which is a big hadron collider trying to just bombard atoms and nuclei with different particles to try to see how they break and fragment off to try to understand how atoms come together even more. All right, so these are things like quarks and bosons and all that type of stuff. This is where that comes from, is doing this. So let's talk about fission first. That's kind of the more applicable to our lives today. So this is where we split. All right, so you're splitting of the nucleus of an atom. Larger particles will split. Either a single particle or you could have multiple particles. They will split into smaller fragments, okay? And this is what this picture's showing. So our guest speaker who came in and talked, this is what he was talking about, how they power, Navy submarines and aircraft carriers, is using this fission process where you've got all this energy coming out, and then you've got released neutrons, and you've got different fragments of what we call daughter nuclei. So guys, these ones that come out, these are called daughter nuclide or nuclide, okay? And then this would be your parent nuclide, okay? Parent nuclide. The parent is the bigger one, the daughter is the smaller one. Okay, note, guys, that energy is produced, okay, in that reaction. I know that's not the greatest looking picture, so this is showing the same thing, is that a neutron comes in, it hits this, and then it splits, and you get all this energy, and you get more neutrons that, again, continues that cycle through all the other atoms in your sample. One disadvantage of fission is that you have thermal pollution, and, thermal, guys, meaning heat, all right, but when it's harnessed correctly, like we already learned from our, like I said, our guest speaker, that heat can then heat up water to form steam, to turn turbines, to create electricity, and that's what's happening in nuclear power plants all over the world, all right? So fission, again, breaking down. You're breaking something down, and then energy is released in that form of breaking something down. Now, on the flip side, you have nuclear fusion. And, of course, I don't think I'm going to be able to get up to where I need to write into. This is kind of the opposite, where you have lighter. Now, this guy's goes up here, okay, in that line. I just can't get to it. Lighter nuclei are combined to produce heavier nucleus or nuclei. So this is doing the opposite. So fission breaks down. Fusion, guys, that term fusion, you are all probably familiar with fusion. Fusing of two things, they're coming together to make one. So in this case, we've got deuterium and tritium. They're coming together to form this big thing, and then we get helium to pop out from it, and then a neutron, but massive amounts of energy as well. So what I have listed for you guys here, just some examples of what you could see in an actual reaction. Now, we're going to get more into these radioactive reactions in the next video and start learning how to kind of figure it out and kind of what we're looking at. But essentially, you have smaller pieces becoming larger pieces. So you're looking at the mass becoming bigger, okay? And there really should be a 1 here with that neutron, all right, wherever you see that neutron. But smaller pieces becoming larger, where fission is taking larger and breaking down. So they're the opposite. Now, advantages of fusion, lots of energy given off. There is no waste that is produced with fusion. The sun is the best example of this. Make sure you are aware of the sun, all right, because it uses that fusion reaction to create energy. It's a natural form of fusion, and then it's unavailable for most part on Earth because it takes so much energy, all right? It takes a lot of heat, and that's one of the disadvantages of fusion, is that you need extreme heat to develop and get this energy reaction to happen. If we could And there's been research, guys, going on for years for this term called cold fusion. Maybe you've heard that before. All right. If scientists could develop cold fusion, where we could do fusion reactions on Earth in controlled settings where it didn't need as much energy to fuse these particles together, it would solve the world's energy crisis. We would no longer ever need, be in need of energy. Fossil fuels would be eliminated. Like, it would just all be done because there'd be so much energy available. But as of right now, that isn't possible. We're trying to get materials strong enough to withstand the necessary heat, but it's very, very hard. So we're still a ways away from that. But if we did, it'd be a perfect solution. Notice, guys, this is a big thing. Both fusion and fission, energy is produced. Okay, so both of them, they're different. One is splitting, fission is splitting, fusion is coming together, but energy is produced all with both of them. Okay, all the time. Now, where's the energy coming from? All right, the total mass of the products is less than the original mass of the reactants, which leads to this thing called a mass defect, where you have a small amount of mass involved in the reaction is lost and converted to energy. Here's that famous equation, E equals mc squared, that Einstein and his colleagues developed, where mass is converted into energy, and this is where it takes a lot of energy to do this. At the right conditions, but essentially that's what's going on. So make sure you know these two terms, guys. They're both producing lots of energy, and this is what can happen. These ones are artificial transmutations, whereas other decays that we're going to talk about in the next video, those are going to be more natural. All right, so I'll see you guys in the next video.